So what if the secret to making AI more reliable wasn't about building a smarter AI, but about building a smarter team of them? Today we're diving into this really cool idea, creating an entire AI office to catch mistakes before they ever become a problem.
All right, let me ask you something. Would you bet your entire company on just one employee? No oversight, no one double-checking their work, just one person handling your most critical tasks? I mean, of course not, right? That would be crazy.
You see, a single worker, no matter how brilliant they are, is always going to be a single point of failure. But a team, an office, well, that has structure, peer review, checks and balances, and that leads to way more reliable work. And it turns out that exact same logic might just be the key to building AI we can actually trust.
So here's what we're going to cover. We're breaking down a research paper that makes this very case. We'll look at why a single AI is a big risk. Then we'll see how to build this AI office. We'll meet the team of rivals that works there and understand the clever defense system they use. And of course, we'll look at the real-world results and talk about the true cost of all this trust.
Okay, so first things first. What is the fundamental problem we're even trying to solve here? Well, it all boils down to the unreliability of a single AI agent, this idea of the lone genius.
The paper puts it perfectly. When a single large language model, the engine behind tools like ChatGPT, when it hallucinates or just gets something wrong, there's no safety net. That mistake just keeps going. And in really important fields like finance or healthcare, a single uncaught error, well, that could be catastrophic.
And yeah, that's pretty much how most AI systems work today. We hire this brilliant digital analyst, give it a task, and just trust the output. For low-stakes stuff, hey, maybe that's fine. But for anything mission-critical, it's like walking a tightrope with no net. It's a massive and often invisible risk.
So let's get to the solution, because it's a really powerful one. The paper suggests this radical shift in thinking. Stop trying to hire a solo AI genius. Instead, start building an entire AI office, one with structure, different roles, and most importantly, oversight.
The whole goal here is to achieve something the researchers call coherence. Now, this isn't about compromise or majority rule. It's about engineering a system where different AI agents, which are designed to have conflicting priorities, all have to agree that the final result is acceptable. It's a unanimous decision, or it's a no-go.
So who exactly works in this AI office? Let's meet the key players, because this is where it gets really interesting. This is the team of rivals. First up, you've got the planners. Think of them as the strategists, the architects. They take what you want, map out a super detailed step-by-step plan, and, this part's absolutely crucial, they define exactly what a successful outcome looks like before a single line of code is written. They literally set the rules of the game.
Then you have the executors. These are the doers, the project managers. They take the blueprint from the planners and they make it happen. They route tasks to specialized agents who actually do the work, like writing the code. Their job is simple. Follow the plan, get it done.
And finally, we have the most important rivals in the whole office, the critics. These guys are the gatekeepers, the quality control. They are totally independent, and their only job is to evaluate the finished work against those success criteria the planner has set up at the very beginning. And they have absolute veto power. If the work isn't good enough, it gets sent straight back. No questions asked, no exceptions.
So, how does this whole team structure actually stop mistakes from slipping through the cracks? Well, the entire system is based on a classic model from safety engineering.
It's called the Swiss cheese model, and it's a brilliant analogy. Picture each AI agent as a slice of Swiss cheese. It's pretty good, but it's not perfect. It's got some holes in it. Now, an error can easily get through one slice. But what happens when you stack multiple slices of cheese? The holes don't line up, and suddenly you have a solid barrier that errors can't get through. That's the core idea here. In practice, this plays out in what's called the critique loop. It's simple, but it's so effective. An executor agent writes some code. A critic agent immediately evaluates it. If it's rejected, boom, it gets sent back for a retry. If it's approved, and only if it's approved, does the work get to move on to the next stage. It's a constant loop of writing, checking, and revising until it's perfect. Okay, so this all sounds fantastic in theory, right? But the real question is, does it actually work? Like in the real world, in a production environment? Let's take a look at the data.
This chart is awesome. It shows you the whole system in action across 522 tasks. Just follow the flow from left to right. You see that big blue river on the left? That's all the initial work. The purple streams are all the times the critics sent work back for revisions. And notice how that flow gets refined and filtered at each step.
By the end, look how tiny that final red rejected stream is compared to the big green approved one. Almost every single error is caught and fixed internally.
And what's the end result of all that filtering? A final success rate of 92.1%. That is incredible. That means for more than 9 out of every 10 tasks, the AI office produced a perfect result with 0 human cleanup needed. So, how did it get there?
Well, the real hero is that first line of defense. The internal critics catch and fix almost 88% of all the initial errors. Just pause and think about that for a second. These are all mistakes that a normal, single AI system would have just passed right along to you.
So after all of those internal checks and balances, the final error rate that ever makes it to a human user is just under 8%. And the paper found that even most of those weren't really failures, but times the AI needed a human to clarify an ambiguous request. The big takeaway here is that the AI office deals with nearly all of the potential problems before you even know they exist.
Now, as you can probably guess, achieving this kind of trust, this level of reliability, it's not free. There's a very clear trade-off you have to make.
This table really breaks down what you're paying for. A single-agent system, it's basically a black box. Your data is exposed, its reasoning is opaque, and it's reviewing its own homework. The AI office, on the other hand, gives you multi-layer validation, a complete audit trail of every decision, and it keeps your data safe. It's really the difference between a wild guess and a verifiable, auditable answer.
And here is the price tag for all of that trust. It costs about 39% more in terms of computation, and it takes about 22% longer. So no, it's not the fastest or the cheapest way to do things. But if you're dealing with critical infrastructure, financial data, or patient records, paying a little more to prevent a catastrophe starts to sound like a pretty fantastic bargain.
And that leaves us with one last big idea to think about. As these AI models get more and more capable, maybe the race isn't just about making them smarter anymore. Maybe the real frontier, the next great challenge that will unlock their true potential in our world, is all about making them provably, structurally trustworthy.